Hi, and welcome to Module 5 of an Introduction to Engineering Mechanics. Before we start today's module, I just wanted to look at an overview of the course again. We've gone through the first major topic already, which is forces and expressing the forces of a vector in 2D and three-dimensional components. The next topic, which we'll start with this module, is particle equilibrium, or looking at the balance of forces on a particle. And so the learning outcomes for today are first to state Newton's first law of motion, which you should be able to recall from your background in physics, and then to express the 2D and 3D equilibrium equations that result from an application of Newton's first law. And then finally, we're going to learn about a graphical tool that we're going to use in applying the equations of equilibrium to real-world problems. And I'll go through the rules on how to draw a free body diagram and sketch that free body diagram, which is a very important a very important tool in engineering mechanics. Okay, so first of all, what I'd like you to do is research Newton's first law of motion, or review Newton's first law of motion, and take a few minutes and write down in your own words what Newton's first law states. Now that you've answered that question, let's look at a definition of Newton's first law of motion. So a particle that's at rest or moving along a straight line with constant velocity will remain in that state when it's not subjected to an unbalanced force. And we call this static equilibrium. And so as a result of that statement of Newton's first law for a particle, we can come up with the static equilibrium equations, which state that the forces, the sum of the forces vectorially, are equal to 0 on the particle if it's to remain in this state of rest or constant velocity. And so in 2 dimensions, we can break that down into scalar equations for 2 orthogonal directions. We might use x and y coordinates, or we might use parallel and perpendicular components. But we'll only come up with 2 independent equations in that case. In 3 dimensions, we'll have 3 independent equations, a balance of forces in the x and the y and the z direction. So let's now, as a last step in this module, look at a procedure for drawing something that's called a free body diagram, or a graphical tool for applying the equations of equilibrium. We're going to use this throughout this course. So the first step is to apply or identify the particle or body of interest that we want to apply equilibrium to. And so in this case, we have this point right here in which we have a tension of the cable that's acting up to the left at a 40-degree angle, and we have another tension in this cable that's acting up to the right at a 50-degree angle, and then we have a weight down of 10 pounds. And so the body or particle of interest that we're interested in is this point right here, which is the intersection of these forces. And so I'm going to draw that down here. I just draw it as a point or a particle. And once we've done that, we sketch the particle free of constraints. And so we look at it as if it's disconnected from the rest of the world, okay, standing there by itself as a particle, and then we apply any external forces that are acting on it. And so in this case, as I mentioned, we have a tension up and to the left in this cable, which I'll call tension 1, and we have a tension up and to the right in this cable, which I'll call tension 2, and then we have a weight down, which is 10 pounds. And the last step in our free body diagram is to add dimensions. And so in this case, the dimensions that we have are these angles, which are 40 degrees and 50 degrees. And so that's a good free body diagram. And you'll find the ability to draw this type of diagram will help us tremendously in applying the equations of equilibrium to find, for instance, the tension in these 2 cables in future problems. That's it for today's module. Thanks.